All right, welcome back, everyone. Thanks for joining this session. And I think we also have here a very, very interesting session about security in robotics. We are going to have three presentations from different speakers here. On the one side, from Victor at Alias Robotics, who's their co-founder of Alias Robotics, who's going to talk about protecting robot endpoints against cyber threats. Then we're going to hear from Federico Maggi, who's actually a researcher at Trend Micro, talking about robotics programming and, well, security-sensitive features. And finally, we are going to hear from Ulrich Seldeslachts from 3if.eu, with talking about the best practices in hardening industrial robotics installations. I think this is a very important topic for robotics today, and therefore I'm really happy that we can have this session. And I would therefore like to introduce you to our colleague from Alias Robotics, Víctor Mayoral Vilches.
All right, thank you, Christoph, for a great introduction, and hi everyone. Hope you're all safe. So I'm really happy to kick off this security session this year, as pointed out, topic of clear importance and centric to robotics. And I'll be speaking about how to protect robot endpoints, robot devices out there being used in real applications. Now, this speech is supported by Alias, the company I'm working with, which essentially brings up about a decade of experience in robotics doing system integration and serving solutions to clients, and brings it down to security. We've been for quite a while working with ROS across different companies and across building and serving different robots. And here are some of the projects that we've lately been involved with. Some of these companies may sound familiar to you. Some of them are pretty big, actually. Here is an example of a client we have engaged with this year, 2020, in the midst of the pandemic, to be honest. This client is making springs for healthcare and automotive applications in pretty sensitive scenarios, I must say. And we're protecting their robots by installing our solution, our robot immune system, directly into the robot. RIS, or our robot immune system, protects the robot by learning about the interactions it typically has and adapting to the particular use case, ensuring that the robotic applications overall remain secure with our constant updates. And speaking about updates, we need to speak about what security really is about, which is a continuous flow and not just a product that you sell once and you go. Security is a process, one that needs to be reviewed constantly, and that needs to actually happen over the different phases of the life cycle of a product or a process. Alias has been working really hard over the last few years. We've been especially active this year, and we're happy to share that we have collected, archived, and cataloged more than 1,000 vulnerabilities for different technologies, all robotic technologies. Out of this more than 1,000, actually we disclosed back to the community openly more than 200, which we put out there in the robot vulnerability database. Thanks a lot for all of these organizations and projects that supported us in the process. We're very, very thankful. Without them, this wouldn't be possible. So thank you once again. And it also has allowed us to serve about 20 companies so far, each one of these with multiple robots in most of the cases. So very, very exciting. Now, when we think about security in robotics, we need to speak about the robotics stack, what a roboticist essentially has at hand and what it uses to build robot applications. ROS, of course, is at the core of most of us roboticists building robot applications. But as you can see, ROS is actually surrounded by more layers, more software and even hardware layers sometimes. So more things need to be considered when we think about security. The best way to realize this in the ROS world is analyzing the ROS computational model, or the ROS computational graph. Most of you may probably know that there's essentially 3 APIs in the ROS world. These APIs allow interaction amongst entities within ROS across different protocols, across different types of elements which happen at the network level. Each one of these elements needs to be considered individually which leads us to conclude that actually we cannot just focus on ROS. Security is an end-to-end effort, especially when securing the robotics stack. And this is what we've been doing for quite a while already. Quite a while ago, actually, we started with this, and one of the first steps we took was building a package dissector and crafter, one that tried to look at the robotics stack, not just at one specific layer, but covering as many as we could. So we built this and we started testing. We started doing static analysis, dynamic analysis. Within dynamic analysis, we did lots of fast testing, which, by the way, was mentioned in the quality session, which I very much encourage you to watch afterwards if you haven't. And we found interesting stuff, some of which we have disclosed, but certainly much, much more that still needs to be patched and mitigated. Here are some of the examples. This flaw, for example, affects versions prior to Jade, including Indigo and many others, and allows an attacker to craft a package, send it to ROS master, and directly crash it, essentially because it exploits a vulnerability in XML, RPC, which forces the ROS master to build a networking package which is huge, and while doing so, essentially it crashes, as you can see over here. So this particular attack, POC, tackles upper layers of the robotics stack. This one shows how a functionality in ROS, actually it's a functionality, this is applicable to all ROS versions, including the latest ones in Noetic. And this functionality is something called shutdown, which isn't very well documented, but it's available if you do code analysis. And it allows an attacker, without any requirements for authentication or authorization, to simply just craft a package, send it up to the master, and literally close it, as you can see over there, with a very nice message in this case. And once again, this applies to lots of systems. This last example that I'm showing here tackles some of the flaws in the underlying layers below ROS TCP particularly. And the reason why we can execute this is because we are not really using sessions as much as we could within ROS TCP. And this empowers attackers to essentially understand the flow with these dissectors I mentioned before, and craft packages which disturb the communication. You can see over there how the average rate, which should be at 10 hertz, is being disrupted. And this could go down as much as the attacker wants, actually, if he or she selects the right packages or crafts them, better said. So you might be wondering, all right, this is interesting, but is it really applicable to real systems? Well, here's an example. This is a real working system that today is up in the cloud. It's accessible, and it is actually subject to some of the vulnerabilities that I've just shown, and many, many more we have internally registered. The interesting thing is that this system actually includes a host-based firewall, which to some is the panacea, but clearly it doesn't contain many of the existing attacks one could execute. And funny fact actually is that this is a reasonably popular company. It has raised a decent amount of resources. Still, security seems to be a pending aspect. So very much work to do and very much needed that all of you engage into security as soon as possible. We went out there and we wanted to dive a bit further. So we went and reached out and tried to search for ROS in the wild. Some of this data, we presented it a year and a couple of years ago when we started doing scannings for ROS systems, classifying them between empty, real, and simulations that we could identify. This year, we're bringing you one step further, which is exactly how do they categorize based on ROS versions. And the interesting thing here is not so much the distribution, which I know is a huge topic of discussion now in this course. I won't get into that. But I will tell you that about 1/5 of the ROS machines which today are out there in the internet are using end-of-life versions. And even if this sounds impressive to you, it is not at all in the industry. There's, I mean, it's very common to find in industry systems that are already in end-of-life, nobody's giving support. So this is something we're going to increasingly see. And take a look, for 54% uses kinetic, which by the way is not so far from being end-of-life. So definitely security solutions are required. And that's where we have been working for the past period. And we're very proud to share that our robot immune system, our smart antivirus for robots, now offers support for 2 ROS-I versions for ROS kinetic and ROS melodic. In a nutshell, the robot immune system offers these 5 capabilities. The first thing is, thanks to the fact that we do proactive research in security, in offensive security, we're able to create adaptive firewalls with these package crafters and dissectors. These adaptive firewalls are able to understand the logic, the flow of the computational graph, and thereby propose proper mechanisms for perimeters. Second module is a hardening module based on the vulnerabilities we identify, both ourselves and other groups which we register. We develop mitigations, which we then zip into ROS. Logging, we do secure logging for forensic purposes. We store logs in using cryptography, which allows us to essentially make sure that when something goes wrong, it's traceable. We also include some visualization capabilities, which allow you to introspect the ROS computational graph using the ROS abstraction, something that becomes pretty handy if you're assessing a system remotely. And finally, we use some very simple, really simple machine learning techniques, which allow us to generalize and try to essentially frustrate attacks that haven't been fully seen using some of these techniques. At this point of the presentation, you might be wondering, well, I've got a ROS system, so maybe I can just use your solution and that's it, right? I'm secure. That might not be it. From our research, we found actually that these robots, all of these robots use ROS, in particular ROS kinetic, to be very transparent. And the interesting thing is that when we pen tested them, we found more security flaws in underlying and above layers than in ROS itself. So this directly correlates with the fact that these systems require a specific solution for each one of them, a robot endpoint security solution. And that's the main topic actually I'd like to share with you, something we've put lots of resources and effort into it. And essentially the need of this doesn't just come from the fact that we do proactive security research and have findings, it also comes from normative requirements. If you take a look out there, you'll see an increasing amount of organizations which are acknowledging that safety requires security. Robotic systems are only safe if they are secure. And actually safety requirements spawn from security research. If you want to dive further into these topics, we recommend you to take a look at these 3 sources. The first one is the meta standard for functional safety, the IEC 61508, which already mentions, by the way, some very interesting approaches which should be taken with regard to cybersecurity. The second one is the IEC 62443, the cybersecurity standard for industry, something we're very close to lately. And the final one, which actually hasn't been fully released just yet, is the new European Machine Directive. There's a preliminary draft, and it already mentions that cybersecurity will be considered a prerequisite. So pretty exciting things coming out in 2021 with regard to cybersecurity. We look forward to it. It wasn't enough, though, for us, for our team, to do this research. We wanted to experimentally validate it. So that's also something we did. We grabbed some of the best-selling and most popular robots in Europe and in the world, and we essentially conducted proof of concept attacks, validating the fact that an attacker could take control of them, could inject ransomware remotely, and could even frustrate the safety systems, disabling it, forcing the robot to collide with itself or with other objects, as you can see, for example, over there. Bringing this all to industry means that these systems need to be protected immediately. So we started acquiring considerations that came from customers and brought essentially the following ones. Systems in industry, systems and robotic processes using robots mostly use security solutions, if they use security solutions that do monitor. They do intrusion detection mostly. Access control and perimeters are static, and this somehow conflicts with some of those claims that host-based firewalls are the solution for everything. Well, unfortunately, they are not, and these static perimeters often conflict with even the computational graph abstractions that ROS proposes. So this is an issue. Endpoints aren't typically secured as part of these industrial security solutions. They are pretty much left aside. guessed as simple PLCs, which only require some integrity checks at best. There's no real security measure for them. Most often, these production systems have very long life cycles, and they are assumed to be secured when they are secured with castle and moat models, which mean that insider threats aren't considered really. We were very scared when we saw all of this, very, very scared. So our reaction was to reach out our network and try to partner with someone that could help us deliver a solution that could help real industries out there. And that's how we ended up partnering with Kaspersky, one of the big companies in the world doing cybersecurity. And together with them, together with their solutions, we developed a coordinated solution which allows to use our robot immune system in coordination with their Kaspersky industrial cybersecurity solution to protect both ICS environments together with their robots. Not just protect them, but also monitor, control, update, and manage them. With this partnership, we managed to make sure that security can be centralized in the Kaspersky management computers, basically. And from there, you can interact with all secured systems, including those ones with our robot immune system. So it was very exciting. But we've been very ambitious. This year, we've worked really hard. And last year, we showed to some of you, or maybe all of you, if you're repeating this year again, that we had support for some of the robots from Universal Robots. This year, we're happy to share that we've gone and supported more than 46 robot endpoints, and this number is growing. We're extremely excited actually to share that we have provided support for many of the KUKA robots, offering security using all of our modules from the visualization to the hardening, secure logging, and so on. You can see actually this video in our booth, so I encourage you to drop by and just say hi. Now, we are pretty happy with the essentially with what we've done so far and with our current solutions, but we want to be a bit more ambitious even, and we want to give you a sneak peek of what's coming real soon and in the coming months. The first thing is security certification. We're super happy to share that we've been working for a while in security certifying our robot immune system across all of our supported robots. We are now able to start committing to projects that require security certification according to ISA 62443. Particularly, we will be providing certification for part 4.2 with security level 1 for now. We're working with a number of parties to do this from Spain, Germany, and Switzerland. So if security certification is something you care about, feel free to reach out. We can definitely help. The next thing we've been working on, and you will see more from us in the coming months, is ROS-2, ROS-2 efforts. We've been working really hard in ROS-2, and contrary to what some believe in the community, thinking that ROS-2 is the panacea for security and that you should move to ROS-2 if you want to be secure. Well, ROS-2 actually is not that mature from a security angle. And I'm not speaking about SROS. SROS-2 is great, and the people behind it is awesome. I'm speaking about the underlying security primitives, the one that live inside of DDS, and particularly the DDS security plugins. These ones are still pretty immature. Most of the DDS vendors are implementing the first releases, and proper testing leads to finding quite a few flaws. To give you a sense of intuition, we currently have in our archive more zero-day vulnerabilities for ROS-2 than for ROS-1. If ROS-2 is something you're considering or you're already investing resources to safety over ROS-2, we definitely encourage you to reach out and consider security immediately. We definitely can help. The last two bits, we're super excited to launch this partnership. Telefónica is one of the biggest Spanish companies and actually one of the top telecommunication providers in the world. They are known as O2 in Germany, I believe. And we've partnered with Telefónica and will open up in 2021 a cybersecurity for robotics lab in Germany, in Munich particularly. We're super excited about this, and the topics we will be researching with their team include 4G, 5G, robotics, and cybersecurity. So if you're thinking about deploying robots in mobile networks, we definitely can help. Last but not least, we're very excited to share about this exciting project. There's not too many public details yet, but we'll be sharing more in the coming months. But we've partnered with public organizations in the European landscape, and we will deploy hundreds of instances of virtual robots throughout the internet. With these instances, which will include, by the way, ROS and physical robots, we will do it so that it's pretty hard to tell if it's a virtualization or a real robot. We're working hard on that. And we aim to collect lots of data with this, data about how attackers behave. And with this, serve everyone better and improve our defensive mechanisms. This is all so far for this year, quite a few things. Hope you enjoyed. And also hope you can enjoy the rest of the sessions. I think we have 2 more security sessions, very, very interesting, coming after myself. So with that, very happy to take questions. Stay safe and stay secure. Thank you so much.
Thank you very much, Victor, for your presentation. It was very, very interesting, and also good luck for the next steps and for the collaboration. Sounds impressive, to be honest. Yeah, thank you very much. And I would say let's directly drop into the next presentation. We're going to answer questions at the end in the panel session. So here I'm really happy to have Federico Maggi from Trend Micro Research here.
Hey everyone.
Hello. And yeah, so Federico, you can go for it.
Thank you very much. Right, so now I guess you should see, yes, you should see my slides being streamed. I work for Trend Micro Research, although this presentation is based on work we did together with Politecnico di Milano, which is a technical university in the north of Italy. And I'm going to give you a slightly more in-depth perspective of what Victor just gave you. So I'm going to dig on one of the layers that Victor spoke about, and specifically application layers. One of the things that stimulated this research is the finding that there are some, I would say, primitive attempts of replicating the App Store model in the robotics ecosystem and the industrial ecosystem in general. These are some examples that we found when we were working in the previous robotic research that we did in 2017. These are app stores that distribute apps for robots, and one of them was that gave us the idea of continuing working on the field. It was a simple application implementing a web server in task program language, and in this case we're talking about ABB. And so you can see in this web server the robot motor states are showed, and basically status information of the robot. Nothing super fancy, right? There's also the possibility of downloading files from the root directory of the robot controller within the web server scope, of course. And by looking at the source code of the application, we found an interesting vulnerability, which normally is found in web applications. And usually web applications work by receiving a URL to request a specific page, for example, 1, 2, 3, 4, and start page. And then they give back the file that was requested within the scope, within the web server root, not outside of it. But the vulnerability that we found made it possible to prepend a couple of, a certain number of // which is the character for going back one directory level, and as the attacker wanted, could go back as many levels as they want, and to steal potentially sensitive files. And we all know that a robot is a gold mine for intellectual property. If you're interested, this is the source code that with a line highlighting the vulnerability. So basically, the programmer was simply concatenating 2 variables without checking the content of the variables. And if you look closely, you find a comment that says, this is left by the original developer. saying, oh, browsers will remove the slash dot dot is on window from a top level request, basically fixing the vulnerability on the client side. Unfortunately, I mean, this shows that the programmer is assuming that all the requests will come from a trusted browser, from a trusted client, respecting the HTTP guidelines, so to speak. But instead, we've just shown that we can craft any request that we want, and we can steal sensitive files. That's just one of the examples. I mean, this was somewhat confirmed. I mean, this lack of awareness was somehow confirmed by the fact that if you go on the most active forums for robotics programming and you search for security-related keywords in these robotics forums, what you find is that the discussions are sometimes completely absent when it comes to security. So in some forums, there's no conversation about security at all. So with this, we can already draw some initial observation. And first of all is that even though the App Store model somehow looks like very futuristic, I mean, we're not seeing that deployed in the wild, right? But it kind of gives us a sneak peek of the future. I mean, how the software delivery model in robotics is going to be more and more streamlined, more faster, right? And that means that if there are vulnerability in the software layer, in the application layer especially, that means that it would be easier for attackers to exploit them. And then third point, we have seen that there is a little discussion about this problem. So I would like to give you now to dig deeper again on proprietary languages, which is, in my opinion, what really needs to be discussed in order to make a fundamental change. And these languages are a whole new world for us working in the IT security field because the languages are new. So it means something new to analyze. And that's one more motivation factor to dig into this research. So I don't think I have to teach you what these manuals are about, because I mean, this conference is all about robotics. You know that all the languages that are used are proprietary, legacy. They have different syntaxes. They have been designed many years ago. So they are basically the critical, probably the most critical piece of software and piece of technology in the robotics ecosystem. If you change this, nothing will work. You can change the operating system. You can almost replace it if you leave the interpreter there. But if you change the languages, you have to overhaul all of the intellectual property that is now implemented in this language. In my opinion, impossible to do in less than 5 years. Anyhow, the interesting part about these languages is that they go beyond just expressing movement instructions. As you can see here, there is a simple loop going back and forth, moving the two joints with a for loop. But what we found more interesting are non-movement instructions, so primitives that allow to do something else. For instance, one of the legitimate use cases is to have functions that support opening or handling files, right, on a robotic controller. It makes sense because maybe you need to have a log of the operations that you do in every day, or maybe you want to make your programs more parametric to receive data from a file and so on. A functionality that was actually more interesting than that is the fact that we found basically the equivalent of function pointers. So this means that by certain functionalities, you could write a program for a robot that accepts other code that will be dynamically allocated at runtime and executed at runtime. So this is the equivalent of, if you're familiar with Android programming, is the equivalent of dynamic code loading, right? This is a very powerful, although dangerous functionality. And of course, all of them support at the application level. I want to stress, we're talking about the application level here. They support communication, which means that it gives the programmer the full ability to interact with networking primitives at the lower level. Great. So the question is, what kind of vulnerability can we find in this? We have seen one example at the beginning. We've seen a path traversal vulnerability. Can we find other vulnerabilities? Can we generalize the concept of vulnerabilities in app level, on the app level, on the task program level? In general, we can say that we have a vulnerability whenever there is a dangerous or unsanitized data flow. So if there is a path going from a sensitive source, such as a file, a network communication, even the teach pendant, because it contains functionalities to enter information. So if you're under an insider threat attacker model, then you can have the teach pendant included as a source of data. And if there is a path from going from an attacker controlled input, so a sensitive source to a sensitive sink, such as a robot movement, file handling or modification, and call by name, most importantly, then you have a vulnerability. And according to our research, one of the most common vulnerabilities that we found in open source programs, I have to stress, are so-called unrestricted movement commands, which means that there is a path going from a network socket to instructions that allows an attacker to move the robot or interact with the movements of the robot in some ways. Which means that this code is, for example, easily found in so-called motion servers, and that's why we're here, because the previous version of ROS makes use of motion servers as for integration purposes. And we found that there are some motion servers which are affected by this issue. Essentially, they do not make any assumption on what the attacker can send to the movement instructions through the network, which means that if the attacker is on the network, then the attacker can directly influence the robot movements. The question is it up to the motion servers to do the validation? Yes, no, who knows? I mean, it really depends on at what point of the data processing you want to make this decision. If you want to leave it up to the motion planner, if you want to do it on the server, it's really up to your application. Sometimes it's not obvious what to do when you find an invalid data. Do you stop the robot? Do you engage in emergency stop? Do you ignore the data point? What do you do? I mean, there can be consequences depending on that decision. So the question now is, okay, we have these vulnerabilities. Can we automatically find them? Can we automatically detect whether a program is affected by those vulnerabilities? We created a tool that is able to parse the source code. For now, we have implemented parsers for ABB and KUKA. But the concept is extensible. So the abstraction allows us to process any control flow graph and turn it into a data flow graph. And once we have the data flow graph, we can make queries. We can say, okay, tell me how many paths are going from network to movement, or from network to file, or network to dynamic code loading. So you can query your abstracted program and ask them if there is any sensitive data flow, which is a potential source of vulnerability. So for instance, this is the example output, is a simple JSON file. And here we have been analyzing a KUKA motion server. It's called, I think, Ethernet KUKA interface. And this is on the right-hand side is the program. And we have found a sensitive source that is the interface, the socket interface, essentially. And we have found that there is a data flow going through several functions all the way to the point-to-point instruction, which is the actuation of the command. Great. So we are able, I mean, an attacker with this vulnerability is able to somehow interact with a robot and affect the movements of the robot in some ways. Of course, the safety system in this scope is fundamental, and it is fundamental to have it configured properly, because the attacker can otherwise go outside the limits and so on. As I said earlier, we found one of these cases in one of the ROS industrial adapters, motion server, but I think it's a bit controversial, as I said, to decide who should fix this and where is the best mitigation strategy. So I would like to thank ROS Industrial Consortium for their very cooperative disclosure process, thanks to which now they have published a nice mitigation document that describes how you should configure your robot to avoid, even if there is a vulnerable motion server, to minimize the possibility for exploitation. So that's a quite informative and very practical guide. There are, of course, other venues for input validation. It is possible that maybe instead of a simple motion server, you're targeting a generic program that, for the sake of code size, right? You want to have a generic call function that receives data from the network and decides which is the function to be called based on the input from the network. And we found one of those cases. Fortunately, this was just an educational code, although this raises the question of why are you teaching? I mean, why are these people teaching how to program using this example? Which, yes, they appear very, very compact and elegant because you don't have a big switch case here. But hey, you just have a straight path from the socket to the name of the function that you want to call. So it means that an attacker on the network can call other functions, right? So there should be something like this instead, which prevents the attacker to send any data that they want. Great. So I said that it's quite hard to find code for, to check whether there is a vulnerability, and that is true. We had a hard time finding good public code because mainly for intellectual property issues. So if any of you have code that would like to be tested, please get in touch with us, and I will see if we could get it through our prototype. I will be very interested to see that. Anyhow, these are some numbers of the vulnerabilities that we found looking on projects hosted mainly on public repositories. I don't have the time to dig too much into the details. I would like to conclude by giving you a different perspective. I want to show you what else can happen instead of just a simple vulnerability. So as Victor showed earlier, if the robot is compromised, yes, there could be ransomware. You could install malware. You can stop the robot. You can have various consequences. I want to show you an example of how these languages themselves are powerful enough so that they allow you to write malware with the same functionalities that you would have in a modern malware, just without the need to use a mainstream language, which means for an attacker, the possibility of bypassing the standard remediation or detection and endpoint solution. So as I told at the beginning, in these languages, we have basically all the primitives that we need. We have network functionalities, which means that we can scan the network for targets, write a malware that scans the network. We can jump to code available at runtime, thanks to the dynamic code loading routines. And the language are very powerful. They are Turing complete, so we can write basically anything. So here's an example of a generic malware dropper. We receive data from a socket, we write it onto a file, then we load that file and execute it. So that's a very generic functionality that is present in almost all of the malware out there, because they need to be upgradable remotely because the attackers want to keep persistence. You can scan network, and here's an example of a simple port scanner that enumerates IPs and ports. We can exfiltrate files because we have file reading capabilities combined with networking capabilities. So it means that we can send files outside once we are on the robot. So we have all of the ingredients. Since I only have about 3 minutes left, I would like to leave the demo up for watching on your own. So I will not project it now. Feel free to head over the ROS Conference 2020 video competition, where you can find a full demonstration of a malware that is able to use these functionalities to self-propagate from one robot to another on the factory floor. So you might wonder now, how about remediations? How do you remediate this specific type of vulnerabilities? Where I would like to organize the thought about over 3 dimensions: existing deployments, new deployments, or future deployments, something that the OEMs have to take care of. Something is about the next generation of robots. So I already talked about what we can do now, and we should always continue doing in the future. That is network segmentation. And please check out the blog post on the ROS Industrial website as a good example of how to configure your network for avoiding the basics attacks. In our paper, Trend Micro white paper, we have published a secure coding practices section that walks you through the basics, even though you don't have experience in security, in secure programming, but you are an industrial programmer or a robot engineer, you can read the basics of input validation, authentication, access control, and output sanitization, which is something that should never be missing in any secure program that you're writing. And last, we have the possibility of doing automated code scanning. Before sending a task program in production, we should go through some automated sanity checks, and that's where our tool comes into play. And for the future, we are really hoping that the vendors will provide an upgrade of the languages and the operating system in order to implement privilege separation, because I didn't tell you, but most of the functionalities that are exposed at the application layer are not mediated enough from the operating system. So you're giving the programmer full power over the system. So for references, I'm going to give you the a couple of URLs here where you can check out the two main papers that we have published on the subject. This is on the left, an academic paper that details the detection tool. And here on the right-hand side, the Trend Micro white paper that details our findings and how to write program in a secure way. Thank you very much.
Thank you, Federico, for this nice presentation. It was very interesting to watch. So a lot of problems there that we probably need to resolve in the future. Well, with that, I would say let's move on to the last presentation, where I'm really happy to have Ulrich Seldeslachts here with a presentation on the best practices in hardening industrial robotics applications. Yeah, so the floor is yours, Ulrich, and yeah, the mic to you.
Thank you so much. Hello, Christoph. Hello, the rest of the viewers here of ROS Industrial. Thanks for inviting us. It's really a pleasure. And it's also an honor coming after those great speakers just before. Both two persons I admire a lot in their perseverance in terms of robotic research, as well as in terms of their entrepreneurship, both with Victor and Federico. So great work from both of you guys. I think you've made some impressive progress. So definitely looking forward to seeing how those things will develop in the very near future. What I wanted to do today is share with you some of best practices that we've seen in some of the applications that we're working with. And to give you a bit of perspective, I'm representing here a number of organizations. The first one is basically the one on the back end here, which is called ELSEC, and that you can see also in the back of myself here. ELSEC is an association of IT security companies that has been around for about 2 decades, was a spin-off of the University of Leuven, and now brings together about 650 companies providing IT security services, products, and technologies, including, for instance, also Trend Micro and Alias Robotics as partners. We are, as a non-profit, basically there to support the transfer of awareness and intelligence about cybersecurity, and that goes into many different directions. One of those directions is using conferences like this, but also in the application of specific projects, which we call innovative projects. So we call ourselves a digital security catalyst, because what we try to do is take the cybersecurity components and technologies and helping those into other different markets and domains, such as, in this case, for instance, everything in relation to industrial. So the TRIF component in this is actually one of our sub-elements, and it stands for Industrial Internet in Flanders, where we are supporting digital transformation with manufacturing companies. And we've been working with about 700 companies over the last 7 years, helping them in taking the necessary steps in becoming much more digital. In that space and that process, we have been developing a number of spin-offs like Factory Sense, which is bringing IoT sensors and digital applications into the factory. And therefore, we can see also how to improve on the efficiency and the technology of the manufacturing companies. We're also participating in a number of innovative projects, such as in this case, Robotics World, together with a project which is called TRINITY. It's a European project. And that project specifically is there to support, as a digital innovation hub, 3 major components. And those are robotics in the first place, Internet of Things, and then we provide the cybersecurity arm to a large extent. With this project specifically, there's a number of things that we do. The project itself has been developing and is developing a number of applications, demonstrators in many different domains. This is one of them, basically developed by Tampere University, where they are using HoloLenses, projectors, and then workspace models in trying to come to an 3D-based map for safety systems. This is based upon ROS, and so I've put the GitHub in there for further reference. Now, beyond this, the Trinity project is actually also working in those different demonstrators and showcasing them, but using different technology modules in supporting different projects and activities out there. Trinity has also opened a demonstration program towards an open call, where we have in the first open call 115 applications from 296 companies. A second open call, which I'll be talking about a little bit later, will be organized in February of 2021, where we'll be offering up to 200,000 euros for innovative projects. And I'm definitely inviting all of the participants here in the ROS Industrial Conference to participate in there. Today, my main topic is about what we started as a main topic for the Cybersecurity for Robotics conference last year. Do not trust robots. And that's also the image that you'll be finding from my end. So it's a basic thought that for every robot that you can find out there, to take the assumption that it should not be trusted. And I think that's a really good basis to start from, especially if you've listened carefully to what both Federico and Victor have been explaining and been talking about. So I think here, what we try to do is to take this to a next step and showcasing this also further into the market. So the first thing that we did a couple of years ago is try to segment those different types of robotic systems out there. And the segmentation is mainly meant to help you and to help industrial companies understanding on how they should take this concept of securing robot systems. Because if you have a controller-operated robot, then it's quite different from a cloud-operated or an IoT-enabled robot. None the least because the IoT-operated robots are, for instance, working with these types of mechanisms, as Federico was mentioning, that they will access, for instance, specific app stores or robot environments to be further operated from the cloud. Otherwise, if this crowd specifically is mainly focusing towards ROS, and so then you avoid basically the typical standard type of programming languages which are offered to you by the different manufacturers. So that brings in some different perspectives, and we'll take the two alongside. So those are different considerations to be made when you are assessing what type of security mechanisms to apply. What we did in Trinity is taking a look into those 19 different demonstrators that I talked to you about just before, which are basically being developed by the different partners within Trinity. And we actually asked all of the different partners, which types of security are you applying within your project? And so this is basically something that we did as an analysis about a year and a half ago. So we basically called out on a very high level risk assessment perspective, what type of security mechanisms are you considering, and what type of security components are you really looking into? And as you can see, there's been a lot of reds and a couple of oranges, and basically only one in green. So most of them were considering some form of access level to take into consideration to secure their robot systems. So not that great. And so when we started taking a look a little bit deeper into those use cases, which is what we have been doing up to now, we basically listed out quite a number of key learnings that we put into a SWOT on those different types of security mechanisms that the different partners were, one, looking into, two, considering, but three, also were trying to implement on the basis of the awareness creation that we've started doing over the last year and a half that we've been participating in Trinity and giving talks like this. And so they've been listening in, they've been hearing quite a lot of potential. And so the good thing that they first started doing is basically applying some of these components. So what they've learned is to raise awareness inside of their own teams. Prevent internet access is the second mechanism that they try to apply. And then as you can see, these are the different components. So 13 out of them that they've started to learn from and try to apply by themselves. And so what we did for the rest of this talk is basically we've divided those into about 20 best practices that we would like to share with you. And I'll be going through them quite speedily because we only have a limited time here. But in any case, they will be available afterwards as well. And you can ask us about those, further detailing those. Some of them have also been mentioned already by both Federico and Victor. Quite normal, of course, when we talk about security and cybersecurity. We'll try to cover some aspects jointly. But in any case, I think what's important here is that the first point about raising awareness, it also means that companies and projects and security researchers are starting to understand that they need to do something about cybersecurity. So taking action is basically really what has been going on. What we've basically found out quite many times and still today, when we go and talk to companies that have installed industrial robots, is basically a sort of resistance because, number one, we don't really know where to start. Yes, we would like to cyber secure our robots, but we don't really know where to start. And if we do know already where to start, we think they're already secure because of the second component here on the list. All of our robots are basically disconnected from the internet. Now, this is the second best excuse that we are hearing. But when we go and investigate, and I'm sure that my colleagues will agree upon this, most robots are actually connected, and it's actually connected through either the host, the bastion, to some cases, or the controller is actually attached to an internet access because somebody needs to be able to provide them with updates or something else. Then there might be a wireless controller active. And so usually when we hear this, and also in most of the cases here, people have started discovering, okay, yeah, maybe we should do something more because, number one, if those controllers might be connected, well, then we're still better off preventing than afterwards ensuring that we need to clean up the security mess that has been created. But secondly, also, in many of those cases, both in terms of research and development areas, people and companies are developing towards afterwards an industrial deployment. And so what we've also discovered is that many of the applications out there might have been set up, also maybe in your case, as a proof of concept case, and that might then after some time be intended to be deployed in an industrial world. But then afterwards, people forget that it has only been deployed for that first level and never been deployed or been tested for really industrial usage. So given also some of the talks that I've heard this morning, I would very much suggest taking an approach of secure by design, cybersecurity by design in this case as well. So let's run quickly through a number of those best practices. VPNs is something that we've heard quite often that is being applied by many of the both industrial cases as well as researchers which are trying to cyber secure their robot systems by implementing VPNs. I think that's a very good approach in the first place, but do consider that also VPNs have issues. And just consider that a couple of months ago already we had a couple of issues with open VPNs. So if you install VPNs, then do make sure that also the OpenVPN or the VPN in this case is hardened and is secured. So every additional security layer that you put in place should also put you into the consideration that you have to consider this, that it has to be protected as well. So a couple of those types of security best practices, as you've seen in this case, for instance, from one of the different partners. Another one that we ensure typically from the top down is start with the risk analysis. So start considering what type of system that you have and take it also from a system approach. So not specifically this robot in itself, but the robot is installed as a wider part of an industrial system. And so how will you take into consideration this whole system into the aspect of where it needs to be put into action? So a holistic approach, taking into consideration what actually the enterprise risk is that you need to be considerate of. Another one is ensuring that the operator endpoint is also carefully protected. In many cases, what we see is that specifically with those types of controller-operated robots or robots which are being steered by a PLC or even the ROS robots, there's somewhere in a specific PC which has been installed to do the instructions towards the controller and acts as a sort of a host towards this environment. But then typically what's being forgotten is that even when they consider that this workstation needs to be separated and segregated on the network, which is another element here, that needs to be protected as well. So endpoint protection for these workstations, something that has been many cases overlooked, even if you consider that it's quite a normal situation. Do detail of the setup and the installation, because in many cases what we figured out is that sometimes people are starting to look into one very specific component of an operating environment. Like people are looking towards, yes, we'll secure the Wi-Fi, we'll secure the connectivity layer, but then they forget about, for instance, how to secure the ROS environment, how to secure, for instance, the different endpoints connected to those environments, or even in this case, the MES consideration. So we've listed out here a couple of things that the partners would need to consider in this case as well. Consider in this case also the use of a Bastion server or a jump server. Not always the better option, but especially when you have to work with legacy systems and outdated operating systems, it's your probably second best option if you're not able to migrate that Windows 7 or Windows XP environment into something new. So especially for those robot operating systems which are running on all the types of Windows, in this case, a Bastion server could be worthwhile considering, especially if you tend to make it a one-way street from the Bastion server to the production server. But still, then do consider that you have to harden, in this case, the Bastion server as well, of course, that you limit it in terms of its access and in terms of accessibility from the outside world. Well, as I said before, Alias is definitely one of our partners, but I think they're very rightful in considering how to implement, in this case, also the RIS endpoint protection. I think it's a very good additional component that some of our partners are considering as well in adding. And something to consider as well is a mechanism where we are considering which types of threats that might be oriented towards such a robot environment. It's a good thing to take a step back and to understand how those robot systems can actually be attacked. And if you take this and you put your hacker hat on for, let's say, a couple of hours or maybe over the weekend, then you'll discover actually quite a number of interesting things. And you don't have to go as far as, for instance, Alias or Trend Micro is doing, but at least it gives you some insights on how an attacker would consider, in this case, your environment as well. And this is a very simple and basic model that already exists for about 2 decades now. So the Stride model, it's considering all of these different components. So if you consider on how to tamper with the integrity of your robot system, then you'll learn how to, maybe we should consider on hardening it in that way as well. A systematic approach is definitely better than a single point. Again, I mentioned it before, but taking this consideration not to focus on one single point, but taking the whole perspective of where the robot is being put into, not only the enterprise environment, so from a risk perspective, but also as part of a cyber physical system that needs to connect. Also, it sends out its data, and it receives controlling data on the other side as well. In some cases, consider also the future in terms of, in this case, for instance, there are many different components that are being utilized when it comes to, for instance, providing TCP/IP. So take into consideration that new types of attack vectors are popping up. So follow, in this case, what types of vulnerabilities that are being exposed. And in this case, for instance, as well, when it comes to, for instance, IoT robots, which might be embedded. We take into consideration that a robot, an industrial robot in this case, is part of a wider industrial control environment. And well, there's many different ways that you can approach this. And also, Victor mentioned it, the IEC 62443 is basically the cybersecurity standard, which is being used by many manufacturing environment and industrial environments. It's not the only one, there's others as well. And you can go even to a very specific, even nuclear type of security consideration. But we do take into consideration IEC 62443 as well. And one of those approaches is segmenting the networks, segmenting the functionalities of where the robot is going to sit. So isolating the robot also within the network and within its operation is definitely something to do. In many cases, what we see is that this is conceptually being applied, but when it's being put into operation, then of course it makes sense to try to get an understanding of what the robot has been doing and trying to get data out of the robot to put into the overall control and the business layer about the MES system. So where is the actual activities going on in this specifically environment? Another one to consider is how does this relate to digital manufacturing? In digital manufacturing, and we have some specific projects in that space as well, we are considering on how to integrate new types of digital functionalities like IoT, but also big data, and how to, for instance, see towards the future how an autonomous factory could actually operate and work. So an autonomous factory in this case would mean, well, okay, it's completely manned with robot systems. So somebody somewhere needs to be able to control all of these robots. So how do we do that? So something to take into consideration also here, that all of these robot systems need to be considered, even if they are being controlled from out of the outside world. I mentioned before, we take a risk-based approach into all of the different considerations that we do. And here is one that I would definitely recommend you. It's from NIST, the NIST 8183, which takes those different components from a very high level up. And so when you take this perspective and you start talking about basically the business owners in this case, or even the production managers, try to identify what potential risks you have and then relay them back into a business process, because this way you will be able to identify where the robot in this case could actually provide some harm. And of course, safety there is a major consideration to be held. And this way we'll also understand that everything related to cybersecurity has to also support things like safety and also physical security. So taking this into consideration, we'll definitely see how to work with potential risks from a higher level up. Do consider which vulnerabilities are out there for the robot systems, but also from the underlying systems that are basically making up the robot. So if you have a robot which is based upon Ubuntu Linux, then do consider how the Linux itself has to be hardened, where you need to try to dive into understanding where some of those vulnerabilities are. In this case, also take a look into what Alias has been doing in trying to uncover and report about the different vulnerabilities that have been found throughout the world on the different robot vendors, and take them into consideration when you develop your own environment. Close to the end here, but 5 more to go. An important one that I think is coming up. I don't think that today we are in a situation that a robot system that has been installed by a vendor that is being mainly also partially maintained by a vendor, which could be a system integrator and partially supported by the manufacturer, needs to be only the responsibility of those entities. No, also the operator, of course, has its responsibilities. And more we'll be seeing that this is about shared responsibilities. It's about shared responsibility in operating the robots, in making sure that the vulnerabilities are being managed and carefully thought through, but also that when a new vulnerability is being discovered by the manufacturer or by the industry, that something is being done in order to make sure that those are getting to the endpoints and to the manufacturing operator. Best practices as well is everything in relation to cybersecurity by design. We've seen it before in Victor's presentation. This continuous agile development consideration is taking place also in manufacturing. And so what we need to do is considering over and over again, how can we cyber secure this process if we have an idea on how to further enhance it, not only once, but also on this continuous loop. So making sure that this happens. Another important one to consider is when we have developed a system, we put it into operation, make a short manual, and try to define what type of security risks might be in there. So it has to be a cybersecurity by design consideration. So cybersecurity bill of material is what we are focusing on. And I'll shortly wrap up, don't worry. Another consideration as number 18, consider new types of approaches. We are working today on what we call secure multi-party computation. It's a very expensive word to say that, yes, we need to consider also how in the future we can share data and share different data from different industrial environments. And how do we do this? How can we do this also in a secured fashion? So relay to secure data, encrypted data coming from one robot system, and share that maybe with others in the industry. That's technically feasible, and so we'll be able to make sure that that happens. And then finally, as I started from the beginning, don't stop asking how can we basically secure our robots. Do not trust robots is a good premise, because this way you'll be able to also ensure that that we can be secure towards the future. If you want to learn more about these different aspects, this Thursday and Friday, we'll organize the Cybersecurity for Robotics Conference 2020. You'd definitely be invited. It's also free to access. So join in, just type on the links here, and we'll be diving into in the IEC 62443 on how it could work for robots. We'll dive into some of the things like safety and actually some real use cases with cobots where safety has been a major issue. So with this, I'd say thanks in any case for listening, and thanks, Christoph, for the opportunity here.
Thank you, Ulrich, for your very nice presentation on the topic. Let's turn to our panel session, I would say. Essentially, one thing I wanted to ask you all, because we are having here like all the security experts in the room about ROS and robotics. On the one side, I wanted to ask, what do you think actually in the future will be the biggest threat? And I mean here, what will be the problems that, let's say, the bad guys, the hackers will use? I mean, here we are looking into robotics and what will most probably be the most profitable threat for the future hackers in robotics. Maybe, Victor, you have a comment on that?
Sure. Well, so I guess envisioning the future is always complicated, right? But I can tell you what we are prototyping internally in our lab. We are doing lots of ransomware. Of course, always in-house, never getting out of our site, and we'll never, by the way. But we are doing this because we see that's how most of the attackers are actually starting to position themselves, mostly because, I mean, attackers generally are motivated by economical reasons. And so their main intention by deploying ransomware is to try to stop productivity or a process. If you are able to inject ransomware in one of these robotic endpoints, you can have and cause substantial damages to the overall economics of the company themselves. So we're experiencing quite a bit with this, and also trying to develop the right defensive mechanisms. So that's one, ransomware. The other one I can share is I'm personally very, very concerned at exploits, which can be very simple, by the way, that essentially bypass safety. This is one of my my personal very big nightmares right now.
Right.
Yeah,
Thanks.
it wouldn't be the first time that safety systems are bypassed. So it's been done in the past in real malware operations. So and the exploits exist, as Victor just reminded us. So I wouldn't be surprised to see attackers targeting safety systems. And another important point I'd like to raise is that recently attackers have been becoming more and more sophisticated at staying in the software supply chain for years, months, right? And then when the time is right, they can launch an attack right from within the software they have Trojanized. And this was an attack that has happened just a few days ago, just to give an example. But still, we are in the pure IT world. Now, if I try to project this in the OT world, which is even more proliferating with proprietary closed systems that have to stay there for years, then I think there are more opportunities to sneak into the software supply chain and stay there, keeping persistence until the time is right to launch the attack. So that, I think, is the scenario that mostly will happen in the near future.
From my end, I'd say I'll add two additional components that I concur with my colleagues here. A thing that we are seeing today, even in some of the robots, which you cannot imagine. I mean, they're so slow, so old, but still they're being used to do cryptojacking, which means that somebody has been installing some form of little malware, and it's being utilized to do some calculations, which are being used for Bitcoins type of collecting or calculations. So not that harmful, but what happens is that the system is basically being overrun, and it starts to fail. So it's not being used for its original intent. And that brings me then to another one, which is basically the use of bots. So also the abuse of the systems which are out there. And like we have seen already a couple of years ago, we'll be seeing the return of botnets by the use of the different IoT or internet-enabled types of robot systems out there, which have simply not yet been fully secured enough. And so therefore being utilized to start attacking other types of devices. The main thing that we are seeing today next to those is using basically the open aspects of the robot systems to lurk into the networks, into the industrial networks, to try to sneak what's available, what are the systems available over a wider period of time, and then to start targeted attacks to something which is maybe much more valuable. With all of this sneaking around and on a very slow basis, is very difficult to figure out from a cybersecurity level. So these are the things that we are seeing today and which will continue to happen in the very near future.
All right, thanks to you all for this, for these comments on that topic. I would have another question. So we don't have that much time anymore. So I would just have one question. Maybe we can start with Federico. Do you in general feel that companies today are more interested in security and are giving it more priority than maybe like 5 years ago, or is it the same?
Yes, definitely more, way more. This is a very good, attitude, I would say. It seems that like for OT systems and industrial systems, it seems that the history is repeating itself. The vulnerabilities that we found in robotics application task programs are syntactically the same vulnerabilities that were found about 15 years ago in web applications, which now have reached a very high maturity level where there can be automated security checks that can be implemented automatically, so that every code that is shipped is automatically checked for vulnerabilities, and with almost no human intervention. So it means that these changes take decades to happen. But I think that now there is enough drivers to implement this attitude also in outside the pure IT industry, so to speak.
I think from the European level, I think it's fully being supported and endorsed as well. And with the ambition of having a digital Europe, where we see also the ambition of much more automation in factories and digital factories in all different aspects, cybersecurity is immediately involved. And basically it's a horizontal approach to the way that we need to make sure that our factories of the future are being secured. That on the one hand side, on the other hand, thanks to conferences like yours, Christoph here, but also ERF and others, the topic of cybersecurity was not on the agenda 5 years ago. So I'd say thanks to your support, and as we see also in many of the upcoming activities in terms of research and new developments, those are popping up. Maybe what's lagging a little bit behind, and maybe that's really a call for all of the manufacturers out there, is to put it also on the agenda, to push it much more towards your clients in a proactive way, and not wait until your clients are starting to ask for it, because I think that's typically the traditional approach that many of the vendors have today. Because our clients are not yet fully asking for it, we don't really have a full offering on it. So, but cybersecurity needs to be absolutely a part of any product and technology being sold out there, and it will be actually a requirement from a regulatory perspective. So every device will have to come with a cybersecurity compliance certificate.
All right. Thank you very much, Ulrich. Thank you very much, Victor and Federico, for this very interesting session. And I wish you all the best with your projects. And let's hear from each other. And with that, I would say thanks for joining, and see you everyone in the next session.
Thank you very much.
All right. Thank you, Christoph.
Thank
Take
you.
care, everyone. Bye-bye.
Bye.